Hey guys, let's go ahead and finish. We're gonna have two more sections on linear or inequalities in general. Today we're going to talk about linear inequalities. Okay. We're going to talk about what they are and how do I graph a linear inequality. Linear inequalities are going to have two variables. So this is an example of a linear inequality. This is another example of a linear inequality. And we call it a linear inequality because it graphs a line. Okay, so what I want you to do right now is I've got 5 different points, and I want you to check each and every one of them and see if they are a solution to that inequality. So remember, put 0 in for x and 0 in for y. Okay, and see if you get a true statement. Then put -1 in for x and 1 in for y and see if you get a true statement. Go ahead, pause the video real quickly and do that, and then you can check your answers when you are finished. All right, so for each of these, number 1 has multiple ordered pairs. It's got 3 ordered pairs. Okay. Number 2 has 2 ordered pairs that are a solution. So right there we have a difference. Well, linear or lines also have many different solutions. So if you remember from our unit on graphing lines, any ordered pair on that line is a solution. Okay. Now, here I've graphed the inequality y is greater than 2x plus 3. And what I want you to notice is these are the points from number 1 on that warm-up. These were not solutions. Okay. However, these were, and I want you to notice that my solutions are in the shade. Okay, so your solutions are in the shade. Okay, and also on the line. Okay, so we're going to look and see how to graph that, but whenever we see this, anything that falls in that shaded area or on the line is part of a solution. Now notice here is different. I use a dotted line. And that dotted line is very much like an open circle. So whatever falls on that line is not part of the solution. As you notice, these 3 things are not in the shade, and they were not part of your solutions. Okay, and then D and E were part of your solutions for number 2. So what does a graphing a linear inequality looks like? We're going to graph it just like we would a linear equation. If it's greater than or less than, the difference is we're going to use a dotted line. And that means that nothing on that line is part of the solution. So it's everything really, really close to that line on the shaded side, but not part of that line. If it's greater than or equal to, that's supposed to be, it's kind of light, or less than or equal to, we're going to use a solid line. Okay. And then we have to shade where all of our different solutions are. And I'm going to show you what that looks like. We can use a test point to do so. So I'm going to graph y is less than 2x, 2/3 x minus 4. I'm going to graph it just like I would a normal equation. So remember, y equals 2/3 x minus 4. Our slope is 2/3, and our y-intercept is 0, -4. So I'm going to go down to 0, -4. I'm going to put my dot there, and I'm going to graph. I'm going to go up 2 and over 3, up 2 and over 3, up 2 and over 3. And I need to stop and think, okay, because this is just less than, there is no line underneath it that means less than or equal to. My line is what we call a dotted line. So everything on the line is not part of the solution. Now it's less than 2/3 x minus 4. So my guess is all of my solutions might be below that line. So what I'm going to do is I'm going to pick a test point. And what do I mean by that? I'm going to pick a point, and it can be whatever point you want. I'm just going to pick that point right there. 1, 2, so it is 2, -5. Okay. So what I'm going to do is I'm going to put that test point into my original inequality. I'm going to get -5 is less than 2/3, I didn't pick a very good test point, times 2 minus 4. Okay. So -5 is less than 2/3 times 2 is going to be 4/3 minus 4. And I can change that 4 into thirds. So it would be minus 12/3. Only my integer rules, 4 minus 12 is 8, so -8/3. So -8/3 is equivalent to approximately -2 2/3. Okay, so -5 is less than -2 2/3. And I know that's true. So that means that my solution is going to be underneath this line. So my solution is going to be everything here. Okay. Now we can also make it a little easier if we wanted to. What if we pick the test point 0, 0? I tend to like 0, 0. That's just me. So if I pick this test point 0, 0, it makes the math a little easier, right? So if I were to do that, I would get 0, I'm putting it into the original, 2/3 times 0 minus 4. Well, 2/3 times 0 is 0. 0 less than -4, that's not true. So if you ever pick a test point and you get a not true statement, that means that the solution is on the opposite side of the line. Okay, so if it's not true, our solution is on opposite side of the line. Abbreviate. All right. So let's take a look at this one, and you can barely see that line underneath there. I'm gonna have to make the fonts bigger or something. Oops. Okay, so it should be greater than or equal to 2x plus 1. So if I go to graph that, again, my slope is -2 or -2/1. My y-intercept, or b, is 0 and 1. So I'm going to go to 0 and 1. My slope is -2, so I know it falls. I'm going to go down 2 and over 1 all the way through. I go up 2, I have to go back 1. And then I'm going to draw my straight line. All right. And 0, 0 is not on that line, so I am going to pick that as my test point. So I'm going to pick 0, 0, which is right here. And I'm going to get 0 is greater than or equal to -2 times 0 plus 1, because I use that 0, 0. And I'm going to get 0 is greater than or equal to +1, because -2 times 0 is 0. I know that's false, so my solution is going to be above the graph. So my solution is all of this up here. So any point that falls on the line or falls within that shade is part of the solution. We've got infinite number of solutions. All right, last example, I believe. So this time 4x minus 5y is less than 20. So this one is in standard form, and remember, I can cover up the y because I'm putting 0 in, boom, and -5 times 0 is 0, and I'm going to get 4x. We're going to graph the equivalent equal to 20. If I divide by 4, our x-intercept is 5. So my x-intercept is 5. Okay. And then my y-intercept, negative 5y equals 20. Divide by negative 5, y is going to be negative 4. Okay. My y-intercept is negative 4. 1, 2, 3, 4. This is just less than, so I'm going to use a dotted line to connect my points. Now, if you don't like, I think this is really easy to graph this way, but if you don't like it, you can go ahead and put it into slope-intercept form. But some of you are still making your mistakes, same mistakes when you do that. So 4x minus 5y is less than 20. If I subtract 4x from both sides, I'm going to get negative 5y is less than negative 4x plus 20. If we divide everything by negative 5, we're going to get y, and we have to flip the order symbol, is greater than positive 4/5 x minus 4. So in this case, our y-intercept is negative 4, and our slope is 4/5. And if you look, you can see that negative 4 is right here. If I go up 4 and over 5, I've got that same point. If I go up 4 and over 5, it's there. So 2 different ways to graph. You do whatever one you're comfortable with. But now I'm going to pick my test point of 0, 0. And I'm going to plug it back into the original equation. So 4 times 0 minus 5 times 0 is less than 20. So 0 minus 0 is less than 20. 0 is less than 20. That's true, so that means that we're going to shade wherever that 0, 0 is, which is up here, and everything up here, but not on the line, is part of the solution. So hopefully today you learned what a linear inequality was and how to graph that linear equality. Have a great day, and I'll see you in class.